Happy Monday, Year 5. I hope you're all well. Just a video here for you because it's Monday morning, going through this week's maths and a recap of what you need to do this week. So a huge well done to all of Year 5, those that took part in the TT Rockstars Challenge against Year 6. We absolutely smashed them. We beat them by over 10,000 points, but a special shout out to Amelia, Lucas and Grace for the top 3 spots. You're on the podium, and every single child that took part, you did really well. That's excellent to see. Next challenge, next battle is 5CP against 5A. I have a feeling this one's going to be really close. So every time you go on to TT, give it a bit more because your class will need your help. So I'm looking forward to seeing who wins this one on Friday, but it's live now, so get going. Now, some of you on My Maths have got multiples revision. You've done it before. Remember 5CP, I say this to you. If I say multiples, you say, and then you used to go times tables. So all we need to remember are our times tables for multiples. Really easy. So our times tables are 5. Remember 5, 10, 15, 20, 25. Our multiples of 6, I say multiples, you say times tables. Well, that's 6, 12, 18, 24. 30, and then the lowest common multiple. Well, common means the same, so which is the lowest common multiple of 5 and 6 in this list? Well, I'm looking. Oh, I can't see any there actually. 5, 10, 15, 20, no, none of those. Okay, so what I'm going to do then, let's do the next multiple of 5. Well, that would be 30. The next one here would be 36. Oh, hold on a second. I've now found that lowest common multiple. It's 30. Okay, so sometimes you have to just extend your list on a bit more. And we know that that's really useful for when we're adding and subtracting fractions. Now, lowest common multiples then. What's the smallest number that's a multiple of both 8 and 12? Well, I say multiples, you say times tables. How are we going to find it? Write your 8s, write your 12s. I know Mrs. Ayton does hers going down. I do mine along. It's fine, it's the same thing. So 8, 16, 24, 32, 40, 48 I'll go for, and then 12, 24, 36, 48. So our lowest common multiple, have you spotted it? Yeah, it is 48. Okay, nice and simple. Now, last week we did perimeter. This week we're doing area. So what is area and how do we measure it? Well, quite simply, area is just the space inside of a shape. So area is a measure of how much space is inside the surface of a shape or the object it covers. Now you can see here faintly we've got A, B and C. Which of those takes up the most space? Well, that's quite an easy one. I hope we'd all say C, but it is a little bit difficult because we don't have any grids, we don't have any measurements to actually measure them. So if I was to do this, okay, and put some grid in there like we've got here. Okay, you've got A, B and C. It's now really easy to count these. So we've got 1 centimetre cubed, 2 centimetres cubed, 3 centimetres cubed, 4. So the area of that is 4 centimetres squared. Sorry, not cubed. B, 1 centimetre squared, 2 centimetres squared, 3 centimetres squared, 4 centimetres squared, 5 centimetres squared, 6 centimetres squared, etc. And you would count them and then you'd end up finding out that C has the most. So it's really easy if we need to just count them. But obviously we don't always have the squares to do that. And as it says here, we call these centimetres squared or centimetres squared written like that. Okay. Now, again, comparing these two, which have the biggest area, not perimeter, not the outside, that's adding area is slightly different. You can't really compare them. They're too close, especially if you don't have any numbers to help us. So that's fine. What about if we put some centimetre squares in then? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 centimetres squared because it's area. You must put the squared on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 centimetres squared. So we would say that that one is bigger, and we know that we can use the crocodile sign to indicate that. Okay. Now, here, obviously, we've got a rectangle. It measures 4 by 5 centimetres, and we want to find the area. Remember, if we were doing the perimeter, we would go 4, 8, and another 10, because that's 5 and that's 5. The perimeter would be 18 centimetres. But this question isn't asking us for the perimeter, it wants to find the area. Okay, well, you know that the area is the space inside the shape, but surely there's a quicker way than counting every time, surely. Well, yes, there is. Okay, we know that here we've got 1, 2, 3, 4, a row of 4 centimetres there. And how many rows do we have? Well, we've got 1 row, 2 rows, 3 rows, 4 rows, 5 rows. So we've got 5 rows, each of 4 centimetres. So actually we can just do 5 times by 4, which we know is 20 centimetres squared. And let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So my method works. So in other words, for the area of a rectangle, we need to do length times by its width. Length here times by the width. 4 times by 5. And you will notice that it meets, those two numbers are at a right angle to each other, 90 degrees. They are perpendicular. And if I jump down to here, we get the answer of a rectangle, the area of a rectangle by multiplying the length by its width. So we can do 4 times by 5, which is 20 squares, or 20 centimetres squared. Okay, so 4 times by 5 area, length times by width. 4 times by 5 is 20 centimetres squared. Easy. Okay, now some of you have got some finding the area of shapes which are like this. Now we've got a parallelogram here. That's okay though, because I've got a grid on here which I can use to help me. We can see we've definitely got 1 centimetre squared there, and this one, if you notice, is half, and that one is half. Well, we know this half here added to that half there makes 1, doesn't it? A half plus a half is 1. So we've got a full square here plus 2 halves there. So the area would be 2 centimetres squared. And the same goes here. We've got a full box there, a full box there, and a full box there. So that's 1, 2, 3 centimetres squared. Plus an extra half is 3.5. Plus an extra half, that's 4 centimetres squared. Well, I've got that extra half there, so it becomes 4.5 centimetres squared. Okay, so that's if we've got halves included. Okay, now that is a triangle, and there is a different way to find the area of a triangle, but we don't need to worry about that until we're in year 6. Okay, and again, right, well, we know it wants the area, not the perimeter. Area is length times by width. So its length here is 8, its width here is 3, so it's going to be its length, which is 8, times by its width, which is 3, so the area would be 24 centimetres squared. If I was to split this into 8, 1, 2, 3, 4, 5, 6, 7, 8, and then split it into 3, you would count that we've got 3, 6, 9, 12, 15, 18, 21, 24 centimetre squares there, so my method definitely works. Okay, now some of you got, again, some slightly harder questions, which says this rectangle covers 40 centimetre squares, and it's written like that. Okay, it has a width of 5, which you can see here. What is its length? Oh, okay, so we know area is length times by width. Now they've told us the area is 40 centimetres squared. So 40 centimetres squared is the same as its length. Well, we've got, we don't have its length, but it's timesing by its width, which they've told us is 5. So it's length times by 5, and we need to work out that one. Okay, it's the question mark just there. Okay, so 40 is the same as something times by 5. Well, what does that something have to be? What do we times 40 by to get to 5? In other words, we can do 40 divided by 5 to give us the length. We do the inverse to find out this missing number here. That's the inverse. We know the inverse of timesing is dividing, and the inverse of dividing is timesing. So 40 divided by 5 is 8. So I think this number here needs to be 8. And I think 8 times by 5 is 40. Okay? Now, again, another question. We need to work out D. We know that the area is the same as the length times by the width. Well, its length here is 9. We don't know its width, D. We need to work that out, but we do know its area is 36. Well, I need to do the inverse then. So I need to do 36 divided by 9, and that will leave me with my question mark. Well, how many 9s in 36? 4. So D is equal to 4. Does 4 times by 9 give me 36? Yes, it does. So I know I've got my answer correct. Now, some of you then have got some revisiting of factors. Remember, factors goes like this. 1 times by 14 makes 14. 2 times by 7 makes 14. So my factors of 14 are 1, 2, 7 and 14. It has 4 factors. Now I'm challenging you now. Which of those are prime numbers? Which of those are prime factors? Now remember, a prime number has only 2 factors. So our primes, okay, are 2, 3, 5, 7, then it's 11, okay, 13, then it would be not 15 because 5 is in 15, it divides into it. 16 is not prime because 8 goes into it. Oh, it's 17, okay, etc. They go right the way up. Now remember as well, a prime number is always next to a multiple of 6 above 5. So these two are not. 2 is the only even prime number, but 6 is there. Fits in there, and 5 and 7 are prime. They're next to 6. The next multiple of 6 is 12. Oh, there you go. You've got 13 and you've got 11. 6, 12. Then you've got 18 here. Oh, 17 is next to it. So it's not always got a number both sides next to it of the multiple of 6. It could just be 1. Okay, but a prime number only has 2 factors. So the factors of 2 are 1 and 2. The factors of 3 are 1 and 3, whereas the factors of 8 are 1 and 8, 2 and 4. So as you see how 8 has 4 factors, 3 only has 2. Okay, now finding the highest common factor of 12 and 16. 12, we do 1 and 12. Remember, my method always works. We don't forget any. 2 and 6, 3 times by 4. Factors of 16, 1 and 16, 2 and 8. And then we would have 4 and 4. Oh, hold on a minute. I wouldn't put 4 twice. We don't. We need to put it once. This has got an odd number of factors, so we know it is a square number because 4 squared is 16. So the highest common factor then of 12 and 16 would be 4. A bit like multiples again, but it's not your times tables. It's the numbers that divide into the given number. Okay. Now, just going back to this one quickly. So what's our prime number, our prime factors? Prime number that's a factor of 14, well, it would be 2 and 7. There are prime numbers that are also factors of 14. Remember, 1 is not prime. So what do you need to remember to do this week? Well, SPAG, there's a sheet on eSchools. English, we're looking forward to reading those. That needs to be submitted by Friday, please. My Maths, Monday, Tuesday, Wednesday. Is on there. You've then got an area sheet similar to last week, which is on eSchools, will be available from Wednesday during Friday. You've got your you've got your Maths Week 25 sheet. I know lots of you have started it already. That's due in on Friday. And of course, Times Table Rockstars and Doodle, TT Rockstars Battle 5A versus 5CP. So that's what you need to do this week. I hope you have an amazing week. And we look forward to getting in all your learning. Again, phone calls will be going home. Children, Mrs. Ayton and I are in school this week. So we might not reply as quickly as we usually do, but we will get back to you as soon as we can. Have a lovely week. Final thing, shout out to Brooke, whose birthday it is today. It's Monday. Brooke, have an amazing day. Mrs. Ayton, Mrs. Perry and I wish you a lovely birthday. And we know that hopefully if we're back soon, we will celebrate with you in school. So have a lovely week. Brooke, have a lovely day. And we will see you all soon.